we will be looking at the review lectures. The trick, or the challenge that we have, at least, is that these review lectures for computer programming 143 has to be done in a very short amount of time. We've got about 30 minutes, right, to get through it. And I want to see if we can do it in 30 minutes because I want to leave some time over for questions. You guys have already seen the slides. You have the slides. You can work through the slides. But now is a great opportunity for you to ask additional questions about the programming environment. We can look at some of the programming stuff together. Here's my Eclipse environment, as you guys can see here on the screen. And okay, but let's quickly look at the slides. So what I am going to do is just run through lecture 4, 5, and 6 very quickly, looking at some of the important aspects that you guys did there. So this is this was lecture 4 of Computer Programming 143, which handles about structured program development. All right, so this is just an overview about where you guys should be about now in the course. As you can see, you're still in the beginning, understanding the fundamentals of programming. So pretty important part to really fix those fundamentals in. All right, we're going to look at structured program development 3.1 to 3.4. What exactly is an if selection structure in section 3.5, and then the if-else, which is 3.6. These things you should have also seen in the practicals up to now. All right, so what is an algorithm? Algorithm essentially defines how we solve problems, okay, in computer programming terms. So it defines the program control, it specifies the order in which the statements are executed, and but instead of just executing these statements, we can also define the order in which these statements are executed. And this is done by using what we call control structures. So we're going to dive in a little bit more into these control structures later. Okay, but for now, something important that you guys should have also seen in the lectures to this point is the concept of pseudocode and also flow diagrams. We're not going to practice this in now. There isn't enough time, but these flow diagrams and pseudocodes allows you to strategically or to systematically tackle the problem that you've got to solve, and just an intermediate step regarding how you're going to solve that in a programming language before actually delving into the details of the programming itself. So it's a very good and useful step for you to just lay out your ideas on a piece of paper. Okay, so that's the pseudocode and the flow diagram. Pseudocode, this is the type of structures that we're going to use for the pseudocode. These circles are when, this represents, it's a graphical representation of an algorithm. It starts at a certain point. The rectangles define type of action. These ovals, these circles defines the beginning or ending of a program or of a particular function or process or procedure. And this diamond sign over here, this one defines a decision that's to be made. So for example, typically we use this when we specify an if. So if the program's going to do something, then the program flow is directed towards a certain part. If it's going to do something else, then another statement is going to be executed. Okay. We've got these 3 control structures available to us in C. Firstly, we've got sequence structures. They're built into C, which basically boils down to the fact that programs are executed sequentially by default. Then we've got the selection structures, and C has 3 types of selection structures. This you should have seen up to now. An if-else, and also a switch. I don't think we've covered the switch up to now, but it's just a very nice ordered way to specify if statements. Okay, and then we've also got these repetition structures, which basically repeats a piece of code. And we have 3 types. We've got a while, a do while, and also a for statement. So this is an example of just a very simple example where this rectangle indicates a statement that has to be executed, and this oval boxes, this is the beginning and this is the end of that particular statement. So now the concept of sequential execution. In C, one statement is done, then after that, C goes on to the next statement. I think some of you, or hopefully all of you up to now, have used the debugger functionality in the Eclipse environment, which also has that very cool function where you can step over certain lines, right? And then you can systematically go from one line to the next and see how your program executes. And the way that it works in C is that everything runs sequentially from one point to another. Okay. So statements are executed one after the other in the order that they are written. Here's an example where we've got to add a grade to a total and update a counter. So this is on the left. We see here this is the pseudocode. We've got our oval statements where it begins. Then we've got our rectangular statements where which execute a certain step. And firstly, we say that we add the grade to the total. This would be a description in pseudocode. And on the right, we've got the actual C code. And after that, we're going to add one to the counter. Here's the description in the rectangular block. And then there's the C code. Okay. Now, the if statement. If statements, you guys should have also been using up to now, basically allows us to choose among alternative courses of action. So, if a student's grade is greater than or equal to 50, you need to print the word pass. Okay, so if this condition is true, then we need to print the statement and go on to the next statement. But if the condition is false, this print statement should be ignored. So in C code, this looks as follows. We've got if grade is greater or equal to 50, then we print it. But we can also, these set of braces can also be removed here because we've got only one line, but it's not good. It's good practice. Even if it is allowable in C, it's good practice to include these braces because that defines the scope of this if statement. Okay. So, all right. Now, this is what the if statement would look like in pseudocode. So, single entry, single exit. There's my little oval signs indicating where I start and where I end. If my grade, there's my diamond. Remember, my diamond was a selection type of component in pseudocode. So if my grade is greater or equal to 50, then I do one leg of it, true, print the word pass, and continue to the exit, to the end of the program. If it is false, just continue to the end of the program. Okay, so that's what it would look like in pseudocode. There's different examples. You can specify, for example, A is not equal to B, and so on. Here's some of the equality operators. Double equal sign means if A is equal to B, and this is A is not equal to B. Very typical problem that you walk into, that even experienced programmers walks into, is in an if statement, you forget one of those equal signs. Then you're essentially assigning one to the other, and that can cause some very difficult debugging. You're going to look for that problem. So if you use equality operator in an if statement, you remember to use the double equal sign. You also have relational operators. Greater than, less than, greater or equal to, or less than equal to is one number greater than the other, and so on. Pretty simple. Here's an example is if 2 is less than 3, then you print that out. If 2 is not equals 3, you print 2 is not equal to 3. Okay, so both of these statements inside those brackets are true, so both of these printf statements will execute. Here's just an example where we bring everything together. So we've got our comments, we've got our include statements, we've got our main. We define two integer num1, num2. We've got the set buff routine over here. Remember the set buff routine, as we've seen in the practicals up to now, that just sorts out the Eclipse environment for the printf statements. Then we print to the screen enter two integers, and I will tell you the relationship they satisfy. So the program is using the scanf routines, which you guys should also have seen to now, to read these two numbers, num1 and num2, into these variables. Okay. If number 1 is equal to number 2, then it prints it out. Num1 is equal to number 2. If num1 is less than number 2, then it prints that out. If num1 is greater than number 2, then it prints that that's the case. And it returns finally. Okay. what is the concept of the if-else statement? So the if-else statement, now what we're doing to the if is we not only have the if part, we're also adding this else. So if this condition isn't met, so if grade is not equal to 50, then it does the part that's in the else. Okay, so if the grade is not greater or equal to 50, then it's going to print failed, otherwise it's going to print passed. This is what it would look like in a pseudocode, in a flow diagram. So in the flow diagram, you've got your start oval, your end oval, and the conditional statement here shown in the diamond block, which is essentially, is the grade greater or equal to 50? Yes, you print passed. False, print failed. All right. And then you can also nest these if-else statements inside each other, like this. Or in terms of C, this is what it would look like. So if the grade is greater or equal to 50, then you can just print A. Otherwise, we can test, is the grade greater or equal to 70, print B, and it'll exit. Or if it's not the case, then it goes down. So this is called nesting. You put one control statement inside each other. Okay. And you can also test, how do you test multiple conditions? This is what you would do in maths, but it doesn't work like this in C. In C, you're going to use the nested if statements for now. Okay, so today you looked at, that day at least, you looked at how decisions are made in C. What is the concept of algorithms, pseudocode, flow diagrams, and control structures? And then you also have these three structures: sequences, if and if-else statements. And now, in the next one, I'm going to look at while repetition structures, how a while works. But before I get to there, I want to ask, does anybody have any questions about this lecture? Nothing. Okay, so let's go on to the next one then. The next one is lecture 5. And what this one is, we're going to start looking now at structured programming development a little bit more. So we're going to look at the while repetition statement primarily. And two program designs. Design 1, which is a counter-controlled repetition, and also program design 2, which is called sentinel controlled repetition. But let's talk about that when we get to that part in the slides. All right, so, okay, we've talked about algorithms, pseudocode, and flow diagrams. I'm going to skip that. Okay, the concept of a repetition structure. A repetition structure is how a programmer specifies that an action, a particular action, has to be repeated while some condition remains true. So in pseudocode, here's an example. While there are more items on my shopping list, purchase next item and cross it off my list. Okay, so you can do this using a while loop. Here's an example. We define a product, int product, and we initialize its value with 2. Then we define this repetition structure that says while this product is less than or equal to 200 times the product with 2. So this loop will execute one after each other. Okay, I think we've got a little bit of time. So what I want to do now is I want to just put this into an Eclipse environment and physically see what happens if we execute that. What happens if we execute that while statement? Sorry. Here is my Eclipse environment. So just going to close this one. I'm going to open a new source file. So, well, let's start with a new project. We can refresh that also a little bit. So I right click here in my Eclipse environment on the left. I say I want a C project, min-gwcc, an empty project. Let's call this weekly review lecture 5. And finish. And then I'm going to right click on it and I'm going to say new. and I want a C source file. Okay. And I want, let's see, while statement .c. It's a default C source template, and I click finish. Okay, so here it is. I'm not going to worry too much about my comments at the moment at the top, but it's good practice to add the comments. And let's write out a very simple program to test the effect of the while statement. Okay, let's first see if we can compile. So printf a is equal to, okay, let's right click here and we say build project. It's executing, everything worked fine, run, and a is equal to 2. This is exactly what we expect. Okay. Now what we're going to do is we're going to put it in our while statement as we have over here. So I just called product, we can change it. Let's change it. Okay, so let's say product as we have in the slides. Product is equal to 2. And we write out the value of product over here. Product is equal to what's over here, okay? And then what did the slide say we're going to do? We're going to put it in a while. So while product is less than or equal to 200, product equals 2 times product. So while product is less than or equal to 200, product is equal to product times 2. Okay, but why don't we print f product in this loop as well and see what it's going to give us? Okay, so the first printf statement, and let's say we're going to start the loop. Starting the loop, like that. Okay, and now we're going to print product inside here. Print product is equal to product, and let's say this is in the loop, is equal to what? Product over here. Okay, let's right click and build this. Everything looks fine. We say run and run. Okay. Now, and let's make it explicit. Ooh, I should add my return statement over here. Return 0. And I just want to printf quitting so that we know that our program has ended. Printf quitting, like that. Okay, I'm going to right click on it. I'm going to build the project. Got it going. Run. Okay, now I'm going to make my output a little bit over here. What happened? What did we see here? We saw that the value, firstly, product was set to 2, right? We printed that out. Product is equal to 2. This is this printf statement over there. We printed this out. Printf, starting the loop. This is this statement over here. Remember, we said in the previous lecture, we said that these statements execute sequentially. Okay, so each of these statements execute one after the other. Now we are in the loop. Product at this stage is 2. And 2 is less than 200, less than or equal to 200. Now we times product with 2. We say product is equal to product times 2. So 2 times 2 is 4, and we print that out here. That's this line. Now that this repetition structure jumps back to this condition, says this new value of product, that's 4, is that still less or equal to 200? Yes. So let's do another iteration of my loop. So now I times 4 by 2, that's 8. And I carry on, and now the last time after 128, my value of product, 128 times 2 is 256. So here it printed out product was 256, jumped up to the stop over here. Is 256 less or equal to 200? No. So my while condition terminated, and the while stopped. Program jumped out of it and said quit. Okay. I hope that's pretty clear what the while statement does. This is what you would do with it in flow diagram format. We have a product is less than or equal to 200. Is it false? Yes. Jumped out, as we saw in the program now. Is it true? Yes. Times it with 2. And go back to this part over here. So this is the loop, the repetition loop that's executed. Okay, so the first part that we'd like to look at is counter-controlled repetition. So a class of 10 students, here's an example, a problem. A class of 10 students took a test. The grades, which are integers in the range of 0 to 100, for this test is available to you, and we need to determine the class average for the test. All right. And we want to do this using loops. We don't want to add each one manually in one very long mathematical format. We want to do this using a loop. So our top level pseudocode, we start off, we're going to think about how we're going to translate this problem from like a paragraph into something that a programmer can understand a little bit better, and then we're going to refine that. So top level pseudocode, determine the class average of the test. And now we're going to start refining it. So we got to initialize variables. We need to input and sum 10 test grades. Then we need to calculate and print the class average. Okay, second refinement, we go a little bit more into detail. So we're going to say set the total to 0, set the counter to 1, and we're going to use this counter to say that we want this loop to repeat 10 times. So while the counter is less than or equal to 10, we're going to input the next grade, we're going to add the grade into the total, and we are going to add 1 to the grade counter. And this counter is the one that's used here to check when we're going to terminate our while loop. And then we're just going to calculate the average by dividing this total by 10, and we're going to print it out. Okay, now here's a C code to show what it looks like. We've got our simple program beginning structure. You guys should know this by now. Includes standard IO and main. And here we go. Here's our variables that we're going to use. The counter, the grade, the total, and the average. All integers. And this setBuff, as I said, fixes eclipse for the scanf for printf statements. Now we need to, before we execute this while loop, okay, it's got a test counter against 10. If counter wasn't initialized, so if you just had this statement over here, this int, it gives it random values. It doesn't initialize it necessarily to anything. So that's why you explicitly initialize it in this phase. Okay, otherwise this while statement can have unpredictable behavior. So now we have counter is equal to 1. We explicitly initialize it, and we also explicitly initialize our total. And we test, is our counter smaller or equal to 10? Is 1 smaller or equal to 10? Yep. So we're going to printf, enter the grade, allow the user to input it, add this grade to the total, which is 0. So the total now has this first input. And then we're just going to increment our counter. So we're going to say counter is equal to counter plus 1, so it becomes 2. And it goes on, goes on, goes on, goes on, goes on, until it gets to 10. It still executes then, right? But the last iteration is going to become 11. 11 is not greater or equal to 10, so it jumps out. And when it jumps out, it calculates the average. Just divide the total by 10 that's been accumulated over here, and we print it out. Now, what happens if we want to change this to process an arbitrary number of grades each time the program is run? So again, our top level code is determine the class average of the test. Our first refinement, however, is still initialize the variables, input the sum and count the test grades, and print the class average. But now our second refinement is becoming a little bit more complex. Okay, so with that, I'm saying that after we've initialized our variables, the user is going to input the first grade, and the purpose here is to have the program continue until the user has entered a sentinel value. So this sentinel value is, for example, if we jump ahead a little bit, if the user has input -1, so we say that the grade can never be -1. If the user inputs -1, that means that he wants to exit from this loop. So it's just an indication of how you're going to exit from the loop, right? The idea with this program is that the user keeps on entering grades until he says, -1, I want to stop now. Okay. So this is what this sentinel condition is. Okay, and here's the program. Similar to the previous one, we're going to go through it in detail, similar to the previous one, but now we've got this sentinel condition over here. So we look at, if the grade is not equal to -1, then we keep on performing this loop. So this loop will continue indefinitely until the user enters -1. You guys are going to use that in this week's practical. Okay, so, but now we need to be careful, because what happens if the user added 0, for example, or something, right? It's always good practice. If you need to divide by a number, if this is not, you need to test, make sure that that number that you're dividing with is not 0. Because if it is 0, then as you saw in the previous practicals, you get a segmentation violation or an error, right? A runtime error. Okay, that's the typical output that you would expect. Okay, let's quickly look at something else called how we're going to define real numbers. I think also in the previous practical, you saw that if you divided two numbers, you got two integer numbers, you got an integer number out. But what happens if we want to start specifying decimal numbers, right? So in engineering, you typically would use decimal numbers. Then you've got to use this special declaration called float. And you can also convert from, say this is an integer, but this average is a float. Then you can use this cast operator, this brackets with float, with the specifier in front of the operation that will convert it into a float. Okay. Here's an example of how you display the floating point number. So let's say my x is 3.446 and x is a float. I can print it out using this %f specifier. Remember, integer was %d, float's %f, and also if I say %f, but in front of the f I have a dot with a number. That dot number specifies how many points after the decimal I want. So here's dot 2, I want 2 points after the decimal. Point 1, I only want 1 point after the decimal. Okay. So today we looked at a bit, on that lecture, we looked at a bit of repetition structures, the while structure, looked at two ways to terminate a while structure, counter-controlled or also sentinel-controlled, and then touched on the usage of floating point numbers, which you guys will see a little bit more in the future of this course. Okay, so the next lecture, which we've got to start with in a minute or so, is based on nested control structures, assignments, increments and decrements operators, and also some formatted input and output. But before we get to that, any questions? You guys should really make use of this opportunity to ask questions. Okay. All right, so then we're going to look at the last lecture. The last lecture here is we're going to round off formatted structured program development and also look a little bit at formatted input and output. So we're going to look at nested control structures, the assignment operators, increment and decrement operators, and also some formatted input and output. All right. Now, let's slowly but surely increase the difficulty level of this problem statement. Okay, so we want to develop a program now that would count and display the number of students that have passed and the number of students that have failed from a list of exam results for 10 students. So, and also now, if more than 8 students have passed, we want to display bonus to the instructor. Okay, so a little bit more conditions there that we've got to capture using our control structures, but not too difficult. Okay, so our top level pseudocode, this is how we understand it as programmers, reads, analyze the exam results and decide if the instructor should receive a bonus. So let's start refining this now, and this also details how we're going to solve it. So first refinement is that we're going to initialize some variables. As I told you guys, pretty important, or very important. Sorry. Then we're going to input the 10 exam grades and count passes and failures, and display a summary of the exam results and decide if the instructor should receive a bonus. Second refinement, we now give more details regarding the variables that we are going to initialize. Initialize the passes to 0, the failures to 0, and also the student counter to 1, because we are only working with 10 students. Remember, that's what the problem statement said. So while the student counter is less than or equal to 10, input the next exam result. But now we've got to use the if control structure to decide what to do. If the student passed, we're going to keep track of the number of passes, else we're going to increment the number of failures. And we're just going to increment the student counter at the end, so that we know where in the while loop we are. Then we're going to display the number of passes, number of failures, and we're also going to say that if the number of students passed is more than 8, then bonus to the instructor. Here's what it looks like in a C program format. Again, we've got our variables, which is initialized now here like this. So you can also initialize variables at the declaration stage. And here we start our while loop. So again, we test, is the number of students less than or equal to 10? If it's not, which it won't be at the onset, because I said that the number of students is 1 in the beginning. 1 is less than or equal to 10, so we start with our while loop over here. We're going to printf, enter the result for the student. Is it pass or a fail? We read that result. If the result is 1, then we say we take it as a pass. If it's anything else, then we say it's a failure. So we don't explicitly test for 2, we just catch any other case using this else statement. And then finally we increment the number of students plus 1. Okay, so yeah, so this is pretty clear. I think this rounds off the while part, but before I continue, are you guys sure everybody's okay up to this point? Okay. Assignment operators. Assignment operators can also be written a little bit differently in what we call maybe a shorthand type of notation. So here's what an assignment operator looks like. C becomes the value of C plus 3. So C can be abbreviated as, but this can be abbreviated, so written in shorthand as C plus equals 3, using this addition assignment operator. In fact, any of these operators can be written as this abbreviated form. So this, we can also use this plus plus and minus minus operator. But it's very important to understand that in some cases, this variable will change, what we call pre-incrementing. So the variable is changed before the expression it is in is evaluated. So care should really be taken if you use something like this in a while statement, or whether you need to use a post-increment statement, C++. If you hesitate or if you're not sure, always use an explicit operator, C equals C plus 1. That will also work always. Okay. Here's just more information about the increment and decrement operators. So what we're going to do, let's say we want to, we say plus plus A, then we say we increment A by 1, and then we use the new value of A in the expression in which it resides. If we post increment it, we can try now in code, we can quickly see at the end, if there's some time left, how this works in Eclipse. Same with the minus. Okay, wait, here is an example. Let's do this. So if we declare a variable called j, we assign j is equal to 5, and we print if we print if j out, but we pre-increment it with a plus plus. it will first do that. It will first increment its value and then print it out. If we add these plus signs at the back of it, post increment, then it'll first use its value in the printf statement, and after that, it'll increment it. So it's going to print out 5. Okay. And if it's not used in an expression, then post and pre-incrementing has the exact same effect. Formatted input and output. Here's just an example where you can use all, depending on the type of the variable. Here's an integer, float, character, and a string, which is a character array. You can use these specifiers in the printf statements to generate various types of output. Here's, for example, if you want to print a big number out as e to the power something, you can use this %e specifier, or float, as I've said, %f, and remember the .2 or .3 to specify the number of decimals at the end. %c prints out a char, so this value is probably an ASCII value for the char, which we print out here. Okay. And another part of formatted output is to specify the area in which the amount of space that is used to print out the value of, for example, an integer over here. So let's say we've got a number 1, 1, 2, 3, 4, with this, and 1, 2, 3, 4, 5 here. And we want to line everything up a little bit. Then we can say we've got 4 spaces to our disposal here. 1, 2, 3, 4. And this one is going to be printed right at the end of that 4 spaces. So that's our area that, if we have the number 1, 2, 3, 4, and we also have 4 spaces, it'll use up all 4 spaces. And if it overwrites it, then it's just going to overwrite it like this. Okay. And here is, you can also then play around with a combination of the two. As I said, the %f can take a dot with a number here that specifies the number of decimals, but you can also add something in front which specifies the maximum space that this float is going to be displayed in. And scanf statements using different types. If the value that you're going to read is an int, you're going to scanf %d, and remember this ampersand, my int. If it's a float, you're going to scanf %f. If it's a double, %lf. This is just a very big float. Yes? Hey? A double is, you'll see, it's a variable type, okay? It's just, I think it's a bigger float. It can hold a much bigger value than a float can, also a decimal, of a decimal type. Okay, so that's what you guys did. Control structures, looking at increment, decrement operators. Be very careful for those, specifically when you use those in program control repetition type structures, to know when something is increment, pre-increment, and post-increment. So good practice is to always explicitly use operator assignments, okay? And then formatted input-output. Probably the best way to learn that is to play around with it. Okay, so printf, a big number, 3.45, whatever, and specify the space in which it has to go, and also the number of decimals that it should have. We've got about 5 minutes or so for questions. Floor is open. Yeah? Yeah. Let's look in Eclipse. Okay, I'm going to do it in Eclipse for everybody. So here's our, sorry. Just want to open our Eclipse environment again. Here's our Eclipse environment. So our question was that what I'm going to do now is let's do it with product. Okay. Let's say product times equals product. It's the same concept as you wanted, let's say, int a is equal to 0, okay? And then we're going to say a plus equals 1. That's what your question was, right? And let's print that out. Okay, so let's print if A is equal to percentage D. Hey. Okay, let's look to this point. What's going to happen? It'll do the other part as well, but I'm just interested now for the question to look at this operator over here. So we right-click on our project. We're going to build it. Let's open our a little bit more here. We look at our compiler output. Everything worked well. Run, run. Okay, so A is equal to 1. Let's do what you asked. Equals plus 1. That's what you asked, right? You right-click here, build project, run, run. In this particular case, it does exactly the same. But I think what they refer to as, what you're thinking about is this statement over here, is if it is used in another statement. So let's print if it like this. A is equal to percentage D. So essentially what I've done here is I've just removed that line. I'm going to do my operator here in my printf statement. Okay. So let's look at this post increment and decrement. Let's see what's going to happen here. We're going to say build project. In this particular case, A is still 0. So I think this is what you're thinking about. Here's where the post increment and decrement comes to play. B is equal. Let's do the same with B. Say A plus plus. Well, let's do it like this. Right-click, build project. My compiler is just telling me that B isn't used, but that's okay. Let's see what the output was with these two statements. So, interestingly, can you see here? So I started off, let's forget about B. B wasn't used. I started off with A is equal to 0, okay? Then I used my post increment operator A++ here, and I printed out the value of A++. And what it does, it'll first execute the printf statement, and then it'll increment its value. So at this point, it becomes 1. And now in this plus plus statement, it first adds 1 to 1, which is 2, and then it prints it out. So then it becomes 2. So I think, yeah, this is the type of, probably for the exams and the test, this is the behavior of the post increment and pre-increment operators that you've got to remember. Okay. No, because it's first going to execute the operator, what it's doing, and that operator is the printf statement. So before doing anything to the variable's value, it's going to use it in the operator, which is the printf. It's going to say, what is it at the moment? It's 0 at the moment. Let's first show that, and then we add 1. Okay. Any other questions? Yes. Sorry, you're going to have to speak up or maybe come to the front. Okay, just hang on. I'm going to come to you and listen. Just, I can't hear. Sorry, man. Okay, so the question was, can you use this A++ in variety of operators? Yes, you can. Let's, for example, use it in an if statement. If A++ is less than equal to 1, this is not good practice, so you shouldn't, but I just want to indicate that you can use it. What we're going to do is we're going to just comment these out so that it's not performed, but let's put it here at the bottom. Okay. If A++ is less than or equal to 1, print if A++ less than or equal to 1. Okay. And let's compile it. We right-click, build project. As you can see, completely allowable syntax there. A++ is less than or equal to 1. Run, run. What happened? A++ is less than or equal to 1. Okay, why? Because A's value is first used in the if statement and still 0 at that point. That's less than 1. Okay, and then it prints that out. But what happens if I'm going to do this? If I do this, I right-click and I build it again and I run it, it doesn't output that. Because the pre-increment operator first increments the value of A, and then it's 1. 1 isn't less than 1, it's equal to 1. It doesn't execute that part. Okay, so that shows you, but it's, as I emphasize again, it's very dangerous operators to use in assignment statements. If you can also do exactly the same thing by just keeping to the normal assignment operators. Okay, this you really have to know what you're doing and understand the intended behavior. Guys, I think we've got to go now, unfortunately, as the next class is probably going to start here. So please also, I urge you to make use of the times that's available, that the lecturers are making available for you to come and ask questions. I personally haven't seen anybody in my office, so either you don't know about it, or you're not making use of that hour. So check again in the class lecturers, ask your lecturers when exactly those times are, and come and speak to us if you don't understand something. Now would be a very good time to sort out any issues that you in the fundamentals. Okay. All right, till next week.